Um, right triangle trig, lots of like flag poles and roofs and looking at things and stuff like that. But here's a couple of just hints to help you really make this easy as we get started. So we talk about vision a lot when we're in these right triangle trig problems. So we have an observer and they're looking up, top of a tree, top of a building, whatever it happens to be, which we always call the angle of elevation because it's going upward. I'm looking up. So here's the part where it can start to get a little more interesting. So let's say instead of down here on the ground and I'm looking up, I'm on top of a building or something and I'm looking down, okay? So I tell people when you're trying to remember the difference between elevation and depression, I mean, if you think of yourself, if you're ever kind of depressed, if you're kind of feeling bad, you're just kind of looking down and things look down. Same thing here, we're looking down at this angle of depression. But let me kind of stress one thing here. Notice when we were doing the angle of elevation, our angle was here, was inside of our right triangle. When we're looking at an angle of depression, it is not inside your triangle, it is technically outside, okay? That can keep us from getting ourselves in trouble in some area. But here's the other thing that's kind of cool about this. Since that line of sight is actually the same whether I'm on top of the building or I'm standing below looking up, if we remember back to geometry, here comes my geometry terminology for the day. If you have two parallel lines that are cut by a transversal, the alternate interior angles are congruent. They're the same thing. So whether you're talking about in an application problem that I'm looking up or I'm looking down, the angle measure is exactly the same. So that should hopefully help keep us out of trouble from wanting to stick this inside when we're talking about angle of depression. And you may even notice me now and then when we do this, it'll talk about depression and I'll still put the angle down here just because I know that's where it is and it makes it a little bit easier for me to keep track of and not do something silly. So, let's make some pictures. All right. I am boring when it comes to this. I always like to put them going the same direction here. So, at a certain time of the day, the angle of elevation of the sun, okay, we can make this a little more. There's the extent of Hardy's artwork. Okay. The angle of elevation of the sun is 44 degrees. I could put a little person down here, but I'm not going to go that far. Find the length of a shadow cast by a building that is 30 meters high. Okay. First issue we got to get taken care of here. Find the length of a shadow. So here's the question. Is the shadow the hypotenuse side or the leg side? The leg side. Because I always tell people, your shadow, you can see it on the ground. It is not like hovering there in a 3D, optical illusion in front of you. It's right there. So whenever we see shadows, shadows are going to be down here. So now we roll back to the last time. So we're like, all right, we got opposite. We got adjacent. With trig functions, opposite over adjacent. Tangent. See, this is a nice exercise too as you're working on these to kind of keep reminding yourself of some things with that stuff. So I got a really important announcement at the end of this lesson too. So remind me. Oh, geez, and then I almost did it wrong. Opposite over adjacent, Hardy. Get it right. So I look and I'm like, all right. If I remember the pattern from last week, I mean, otherwise I could multiply both sides by x and then divide. But if x is in the denominator, remember, you're just dividing the 30 by your trig function. That's where we're going to end up. And also, reminder, always make sure somebody hasn't been a stinker. Okay, we're in degree mode. Got to be in degree mode. 30 divided by the tangent of 44. So 31, we're rounding the nearest 10, 31.1. And we're good. So as we play with these, you're like, they're basically all going to set up the same way, except with maybe where your sides are. That's really going to be true. So we got a parasailer attached to a boat. Okay, so here's my boat. Here's my parasailer. I'm not good enough to put the like parachute on there. So he's just kind of hovering in the air up here. So the rope is 80 feet long from the boat to the parasailer. We don't want it down here. The parasailer's in the water. It's water skiing if the 80's down here. The angle of elevation from the boat to the parasailer is 36 degrees. Find the parasailer's height above the boat. So that'll be the biggest challenge if there's not a picture there for you, figuring out, okay, which sides am I using? So let's see here. Opposite, hypotenuse. What trig function we got rolling this time? Sine. Everybody likes sine. Like it's the first one, it's the one we remember. Opposite over hypotenuse. When it's a number in the denominator, we're multiplying the trig function times our side. Let's see here. 80 sine of 36. 47 straight up. Are we feet? We are. No decimally this time since we're going to the 10th. So, I mean, to be honest, I think that's the only thing that could even throw us off at all, to be perfectly straight. I mean, there's always got to be something that can throw things off here. All right, let's see. From the top of a lighthouse. All right, hang on a minute here. All right, lighthouse. Little window. Sure. Okay. The angle of the depression to a buoy is 25 degrees. Okay. Reminder. When we chat depression, technically that 25-degree angle that I'm looking down at is out here. But because of alternate interior angles, that 25 is also here. It's in the exact same spot that elevation is. So when you see elevation versus depression, really the angle's in the same spot. So we can we can cheat a little bit that way. So if the top of the lighthouse is 150 feet above sea level, find the distance from the buoy to the foot, the bottom of the lighthouse. Still got to play with words here. And so once I work that out, there's my oppo. We're attached here. There's my adjacent. Opposite and adjacent is tangent. And like we saw back on number 1, we're dividing by x, which means we're going to be dividing our side by our trig function. And again, stop to think for a moment, too, if your answer seems reasonable. If it's 150 feet tall, could it be 321? Sure. Like, if I'd have gotten, like, 3.21, that probably is not going to work real well. So either my mode's off or something else like that. Like, why are we doing so many? They all end up the same way. Here comes the twist. A park ranger whose eye level is 5 feet above the ground measures the angle of elevation to the top of an eruption of Old Faithful. Geyser. Almost said geyser. Oh boy. To be 34.6 degrees. If the ranger is standing 200 feet from the geyser's base, what is the height of the eruption to the nearest tenth of a foot? Okay. So here's where life gets a little more interesting. So they got an angle of elevation. The ranger, doing that for a purpose, is standing 200 feet from the base. What is the height of the eruption to the nearest tenth of a foot? Okay. Suggestions from me. A park ranger whose eye level is 5 feet above the ground. Okay. Here comes the twist. I'm going to tell you how I normally would handle it, and then you can kind of figure out how you would want to play this and why I don't try to play this all at once. I'm going to ignore the eye level part for a minute. I'm just going to solve this like I've solved every other one that we've done so far, and I'll explain why I'm going to do it that way. So we got opposite, and we got adjacent. So we are back to tangent again. So I get to here, so we got 200 times the tangent of 34.6. So we're looking at like 138 feet. But that's not taking into consideration the park ranger. So this 138 gets me to here, but we've still got the extra 5 feet that we need to take into consideration. So why didn't I, back at the beginning of this, just include the 5? Because people's mindset on this in the past has seemed to get a little bit off, because everybody thinks, okay, so that's 5 feet. Just make it x plus 5. Problem is, algebraically, at the end, you're going to end up subtracting the 5 if you do that. So if you're going to do this, technically, we actually make that x minus 5, which goes against everything you would think is going to be, and it tended to confuse people more. So I always tell people this is why it's important to draw the picture, so you can have that reminder there, oh crap, at the end I've got to add the 5 or this isn't going to work. Now, if you can put all that together and not get thrown off by putting the minus 5, that would let you get the entire answer at once, but something I normally don't get myself into, because I know I could get myself in trouble with some of that. So, here's the game plan. Game plan today, we are going into word problem practice. Sometimes nice, gave you a picture. Sometimes not so nice, didn't give you a picture. And you're like, wait, Hardy, there's no answers in here at all. What the heck? So here's what I'm going to do on that front. I do have answers up front, okay? I will even here momentarily, I'm not going to put it on the video, I'll put it up on the screen. I'll put odd answers just straight up there if you want to kind of know where you're heading with things. But I'm also going to post some answers on Classroom tonight just so you can kind of be checking things, make sure things are going well. And I'm going to cross my fingers that we're not using them for nefarious purposes like copying or something like that. So with that, let me